There's a lot of talk about Saturn's rings, but what about Uranus's? If Saturn's rings are so iconic that they even have their own special name, the rings of the system, then why do we know so little about those of Uranus? What makes them so mysterious? In this video, we'll be covering a recent discovery related to the rings of Uranus that has scientists baffled. But before we get into it, be sure to hit that like button for more videos about the amazing discoveries coming out of NASA and other space agencies. And stick around until the end to find out how you can receive updates about our future videos. When it comes to planetary rings, Saturn's are by far the largest and most complex. They stretch thousands of kilometers wide and hundreds of kilometers thick. In comparison, Uranus's rings are much narrower and not nearly as bright. From what we can tell, they are only about 30 meters wide and couldn't be seen until the Voyager 2 probe flew by Uranus in 1986. However, despite their seemingly simple appearance, there are some things about Uranus's rings that don't quite add up. For example, the rings of Uranus are surprisingly dark. Given that they're opaque enough to cast shadows, it seemed odd that they weren't reflecting more light from the sun. Scientists thought that maybe they were made of ice, just like Saturn's rings. But if that were true, then shouldn't they be sparkling and shimmering under the sun, or maybe they're made of rock? Rock is known to be great at absorbing heat, so it could explain why the rings didn't reflect any light. But if that's the case, where did all the heat go? It shouldn't be possible for such young rings to cool down so quickly. It was only when Voyager 2 approached Uranus that scientists realized the truth. The rings are intermediate in complexity. They're not as extensive as Saturn's, but they're also not as simple as Jupiter's, Neptune's, or Jupiter's rings. Uranus's rings are made of ice crystals that are opaque enough to absorb most of the sunlight hitting them. Think of them kind of like fog. When you see fog, you can usually make out the shapes of things behind it, but because of its density, it casts long shadows and makes everything seem darker. But here's where things get interesting. Unlike Saturn's rings, which are believed to be billions of years old, Uranus's rings are likely only tens of millions of years old. That means they should be glowing like a fresh snowfall, not dull and lifeless. So what happened to all their sparkle? Why are they so dark? One possible explanation is that the ice crystals have somehow become opaque. Normally, ice crystals reflect a lot of light because of the way they refract it. Light travels differently through ice than it does through air, so it bends as it passes from one medium to the other. This bending of light is called refraction, and it is the reason why you can see objects underwater that are at a different angle than you'd expect. Since light travels slower through ice than it does through air, it bends away from the normal. This is called positive refraction. And it's the opposite of what happens on the surface of a concave lens, which is why ice crystals often sparkle and shine. However, if the ice crystals are small enough, their refractive effect can actually cause them to absorb light instead of reflecting it. This happens when the size of the ice crystals is comparable to the wavelength of visible light. At that point, the ice crystals start trapping light inside them, and they'll eventually convert it to heat, releasing it back into space. So while Saturn's rings might be ancient and composed of larger ice crystals that still reflect and shine, Uranus's rings are younger and composed of smaller ice crystals that absorb and darken. But there's another theory as well. According to this one, the rings aren't opaque. Instead, the ice crystals have become so perfectly aligned that they're effectively one giant crystal. Imagine a forest of perfectly straight, perfectly aligned trees. You could see between them, but it would be hard to make out any individual branches. Now imagine those trees were only 30 meters apart. That's basically what it's like trying to look through Uranus's rings. But just because the rings aren't opaque doesn't mean they won't cast shadows. Think of smoke. Smoke particles are too small to see individually, but if there's enough of it, it can block your view and even leave shadows on the walls behind it. The same is likely happening with Uranus's rings. The ice crystals are too small to see individually, but they're aligned in the same direction, which causes them to reflect and cast shadows in a way that looks like they're solid objects. But even this doesn't fully explain why the rings are so dark. After all, ice is usually white. Something else must be darkening the ice crystals, preventing them from shining. One possibility is that they're covered in a thin layer of soot. Soot is a form of carbon that's produced when organic matter burns. It's black and opaque, so it would easily explain why the rings are so dark. But where did the soot come from? Well, one theory is that it came from meteors. Meteorites constantly bombard the rings, leaving behind a thin layer of soot that covers the ice crystals. Alternatively, the soot could be coming from the atmosphere of Uranus itself. Uranus has a very thin atmosphere, so it's possible that some of the gases could be escaping into space and forming soot. Or maybe the soot is being blown over from Saturn's rings. Saturn's rings are much larger and more complex than Uranus's, so they produce a strong gravitational pull. It is possible that this is strong enough to pull soot off of Saturn and deposit it on Uranus. The good news is that we may finally be able to put this mystery to rest soon. NASA's new James Webb Space Telescope should be able to see Uranus's rings in much greater detail. With a bit of luck, we'll be able to figure out what's darkening them and whether or not they read truly as young as we think. Speaking of age, there's something else that's been puzzling scientists about Uranus's rings. Some of them appear to be warped or misshapen. Take a look at this image. Do you see anything strange? There's an obvious dark band running through the middle of the ring, dividing it into two separate sections. What's going on here? This isn't the only ring with this strange phenomenon either. A similar one can be seen here, and no, it's not an artifact of the image or a camera error. These bands really are part of the rings, but what caused them to warp like that? Well, according to scientists, it could be the result of invisible moonlets. Moonlets are small, irregularly shaped moons that orbit close to their planets. They're usually only a few kilometers across, so they're hard to spot, and that seems to be the case here. There are several small, dark spots scattered throughout Uranus's rings, and scientists believe that these spots are actually moonlets. These moonlets would have formed in the early days of the solar system when Uranus was gathering together its rings. As the rings swirled around Uranus, they began to clump together in some places and spread apart in others. This created a sort of hilly landscape with high peaks and low valleys. Over time, the clumps became denser and the valleys became deeper until they eventually collapsed, forming the moonlets we see today. But if that's true, then why aren't these moonlets crashing into each other? After all, they're only a few dozen kilometers apart. Well, it turns out that the distance between them is exactly what prevents them from colliding. If they were any closer, they would have already crashed into each other. But this distance also means that they're just barely held together by Uranus's gravity. As the moonlets orbit Uranus, they create a gravitational pull that stretches and deforms the rings. This is what causes the bands to warp. Each moonlet has its own gravitational pull, so the rings around them are stretched and deformed in different ways. Eventually, the moonlets will get too far apart and the rings will snap back into place. But until then, they'll continue to stretch and warp the rings, creating those strange bands we see today. So the rings of Uranus may be simpler than those of Saturn, but they're certainly no less mysterious. Who knows what other secrets they're hiding? Maybe in a few million years, they'll vanish altogether. A team of researchers used computer models to simulate the evolution of Uranus's rings and found that they might disappear in just a few million years. The ice crystals would eventually drift apart, causing the rings to become invisible. Of course, this is only a theory, but it's an intriguing one nonetheless. Maybe in a few million years, Uranus will be nothing more than a pale blue dot in the night sky. What do you think? Is there anything we missed? Let us know in the comments below, And don't forget to subscribe so you don't miss out on future videos. We've got lots more videos about the amazing discoveries coming out of NASA and other space agencies.